Now, let's see how we can find the probability distribution function of a continuous random variable when its density function is given by a simple but piecewise defined function. So first we recall what a probability distribution function is, or how it is defined. So we have, according to our definition, this is the cumulative probability for the continuous random variable to be less than or equal to little x. X is any number between negative infinity to positive infinity. By the definition of a continuous random variable, its probability is from negative infinity to x, and then put the density function over here. So this is the definition function. This is the definition of the distribution function. Now, this function over here is piecewise defined. This is just a definite integral, but it looks like an improper integral. It's not really an improper integral because the function is 0 beyond this interval. The easiest way would be simply look at what kind of function we are integrating over here. So let's sketch the function of this density function. So the density function looks like this. This is negative 1/4, and here we have positive 3/4. It's not really drawn to the scale, but it's good enough. So this is constant 1 over here, and beyond this one over here is 0 again, and this is 0 over here again. Okay, and here we have to discontinue this over here. So this is our little f of t if we want to, because x is now reserved for the upper limit over here. So t over here is a dummy variable we use. Okay. And to integrate this function from negative infinity to x, so we go from this over here is negative infinity, and to x, we know this definite integral has a geometrical interpretation. The function over here is non-negative, so it's the area beneath the curve, but it depends on where this x is. So we actually need to look at 3 situations. We have the following. If x is less than or equal to negative 1/4, okay, so that means x is somewhere over here. And then from negative infinity to negative 1/4, our function has 0 value. So what we have over here is that f of x is simply going to be, we can copy down this formula, the definition, ft dt. But x being less than or equal to negative 1/4, we have this one integral over here. It's exactly negative 1 to x over here. We have 0 value dt. Everything is 0. So this value over here is simply 0, because value over here between x and negative infinity is 0. Now, if x moves into this interval, then we have a different function over here, or we have a little bit more than 0. And we have to, in fact, we have to split the integral over here into 2. So if x now is located within negative 1/4 and 3/4 over here, so somewhere in the middle, then of course our definition has not changed. It's from negative infinity to x and ft and dt over here. And then what we have over here, we have 2 integrals from negative infinity to negative 1/4. And still we have 0 value over here, dt. Okay, and plus another interval from negative 1/4 to x. That's where we have negative 1/4 to x over here. And then within this interval, the function's value is 1, so we have 1 dt. And if we evaluate this one over here, this is 0, and this one over here is t. And we plug in upper and lower limit, that's x and negative 1/4. So we have x minus negative 1/4, and this is going to be x plus 1/4. Okay. And this is true if x is between this interval from negative 1/4 to positive 3/4. Okay. Now, if we have x beyond this interval, if x is bigger than or equal to 3/4, so what's going to happen? And then we have f of x over here. We have actually 3 segments. Still, let's just copy this definition just for one more time to get familiar with this formula. But now we have, let me move over here. We have 3 segments. First, from negative infinity to negative 1/4. Now x is somewhere over here, so we have this segment, and this segment. And within this interval, your little f of t takes 0 value. And then from negative 1/4 to 3/4 over here, and the value is 1 and dt. And then we have another segment that's from 3/4 to x over here, and the value again over here is 0 and dt. And evaluate this one, we have 0 over here, and this is going to be 1, and this is going to be 0, so this is 1. And put all these things together, we have the following distribution function. F of x is equal to 0 if x is within this interval, negative infinity to negative 1/4 over here. And it's going to be x plus 1/4 if x is inside negative 1/4 and 3/4. Okay. And it's 1 if x is inside 3/4 to positive infinity. Okay. And we can also easily sketch its graph over here. I cannot really draw very straight, but we have negative 1/4 over here and 3/4 over here. Between negative infinity to negative 1/4, we have 0. Okay, just a little bit above 0, so you can see it. And then this is the one that's x is equal to. This is x is plus 1/4 over here. Okay, that this point over here should be 1/4, and angle is 45 degrees over here. Okay. And then after that one, it's again straight line over here is 1, and this is over here. The value is over here is 1. Okay, and this is non-decreasing. Negative infinity go to 0 over here, and positive infinity the value approaches 1, and this probability distribution function. Okay.